So last we left off, I did some bad things. No, wait a minute. That's not my fault. Why would I do that? By the way, reason for this is because it was really super windy and I didn't want sand blowing in there and causing all kinds of hell. We're going to go through what bad choices are all about. And I have no idea what bad choices I could have possibly made, but this may or may not have been my fault. As you can see, this is a two-piece unit, and it was originally designed to be not apart from one another. And this is the new and improved part. So I can go from busted ass tractor to repaired. And this is a beautiful piece. I mean, seriously, those are some really impressive welds. Whoever did that, hats off, dude. And that's a really good welder too. Probably at least 300 amp setup. It's just gorgeous. Welds are gorgeous. So, love Craftsman, man. This is American made parts. Just saying. But anyway, so what happened is the wheel got cocked with the loader and went into a little bit of a recession when we were moving some dirt, and didn't realize it was cocked. And so this may or may not be my fault. Okay, I gotta own it. It's my fault. I backed up. It just snapped the axle off. It would have never happened if I hadn't made that mistake. But I will be doing I'm going to weld this, and I'm going to keep this for a spare, and I'm going to weld it, and I'm going to modify it. I'm going to make it super, super, super strong so it will never break again. And as you can see, this was an extremely, extremely sharp snap because it's super clean. Now, I've cleaned it all up, burnt all the paint off it. That's why all that white stuff. And because I want to be welding on it, I will be sandblasting all this so it's super clean. This is going to be chamfer ground, so it's going to be all beveled in. There's going to be a drill hole in the center of it when I get my drill press up and running and build a jig for this so it can be straight. And I'm going to drill this and pin this with a 1-inch pin, not 1-inch diameter, 1-inch long, about, I'd probably a 5/16 pin. And the reason for that is to hold this super steady. I will also make a jig for it to go in, a rotating jig, so that I can weld around and keep going around and around. But this is complicated because you have to get that part super hot and you have to get that part super hot so this metal and the weld bonds. Otherwise, it's never going to work. It'll snap again right away. And I got taught this trick by an old blacksmith when I was a kid. So I'm going to make a whole video on that at some point in time. So now that we got this new part, we can start going back together. And there's some issues with the seal that it's kind of buggered up. So I'm going to be straightening that. And I guess people would like to see me actually do things, but I don't have a really cool way of holding my camera. Yeah, don't look at that. That's an erector set thing. I haven't finished it yet, but I'm going to make a thing for this to hold my camera. Hold my cell phone, because videos are so much easier to make and edit on my cell phone. And I just released a video a little bit ago. I don't think it's posted yet, but I just released that. Also, I want to point out, and the mother of invention again, I went to take this apart, get the old parts apart, and realized that someone put a nail in there over a cotter pin. We're not going to put it together that way. We're also going to clean all the parts up, and as you can note, there's a gasket that goes around here. Well, that gasket you can't buy, and if I had gasket material, I would make one, and it looks pretty crappy, but I will probably, for now, just use some silicone sealant around there to keep any kind of water out, but not enough so it gets in the bearing area, and I'll obviously plug so no crap gets in here when I go clean this off. I may just scrape it as good as possible versus I usually take a wire wheel to it and really super clean it to bare metal. I don't know that I'm going to do that this time just because I want a gasket for it when I can find one or make one or what have you, but I need this tractor back online like yesterday already. I got a hats off to the company I get parts from. I'm going to do a shameless plug for these guys because I called them up. They were super, super helpful. And let's see if I can find it. It's a Parts Fulfillment Center. It's out of Lake Mills, Iowa. They have everything you could ever want, need, or desire, either in used parts or new parts for Farmall tractors, Alice Chalmers, Case, John Deere. And seriously, I don't know how deep this goes as far as what they can get, but I'm going to tell you, I called them up, and my 1947 Farmall H, they had a whole overhaul kit for that. They had this this spindle, and this is not a Farmall spindle. This is a Schwartz front end, which is a common front end that was put on these tractors. So that's why everything is a little weird and a little bit different and not so easy to get. You can't buy this stuff on eBay. They do some advertising. Also, the subsidiary company of this company is Yesterday's Tractor. Okay? So, if you've ever looked up the age of a tractor or whatever, you probably, and wanted info on it, you probably went to Yesterday's Tractor to find it. So, this is part of this company. So, not only do they have the statistics on everything, but they have that, and then they have links to other companies that they own that literally have parts breakdowns, like for my 504 Farmall, 504 Farmall, I needed to understand the whole hydraulic system and what components are there because I believe I have a blown O-ring on the back of the pump. Well, I couldn't get anywhere with Case because they didn't have any kind of a breakdown that wasn't like hieroglyphics. And these guys had a link to a website, and a gentleman helped me. That Lewis helped me with that and got me a link to that. And I was just absolutely tickled to death because I was able to see where the problem is. Yes, I haven't painted this damn boat yet. Been kind of busy with other things, trying to get some kind of software program so I could take all of the videos that ended up on my laptop before I started using my cell phone exclusively, trying to get those videos on there. So I need to get some rubber gloves on because I'm going to be handling some grease, but the first thing I'm going to do is probably put this actual shaft back in its respective hole and then start working on the components that are going to have to go on here. Now, the seal on this is very unique, and I'm not sure where I sat that because it needed to have some rework done to it. It actually presses on the back side of the shaft. No, it's not over there. Don't mind the mess. I fabricate up a lot of really weird stuff. Don't throw anything away because if I do, I don't know how many times I've dug a piece of iron out of there and made stuff for someone. It's a ridiculous amount of times. There's always something. Somebody breaks something, they always come to me to fix it for some bizarre reason. It must be my bizarre skill set. Oh, that's where the seal is. And I'm also going to be repacking these bearings. I'm going to clean them up a little bit. I don't know that I'm going to super clean them because this has got some really good grease in there. But I'm also going to just repack them as long as I'm there. This isn't like bearing buddies where you just pump a whole bunch of grease in there. You pack these like the front wheel bearings of a car, and they just stay packed however they're packed for however long until you do it again. Now I want to show you the seal here. Yeah, I broke another light. Backed into something. Okay, so this is a unique seal on the Farmalls. Now, this beveled edge here, This beveled edge goes to the inside of the axle and is legitimately pressed on to the axle, and then this 3-rib seal actually goes the bearing, and then the bearing gets put on next that holds this in there. So you got to drive the bearings on and this seal on and the bearing on the inside bearing. So it's kind of backwards on how you would do it on a boat trailer or a car or anything like that. You would put that stuff inside the hub assembly, but this is quite a bit different because this fits on this bevel edge up against the axle shoulder all the way to the back. Okay, then the bearing, and then you put the hub on, and then you put the outside bearing in, and you put the nut on, and then set your preload, and then back off a little bit so it's not super tight. Never want any bearing running super tight. All you're going to do is crush that bearing and make it ride stupid in the race. It's not going to be happy, and it's just going to fail at some point. But as you can see, that this has some damage, and I've got a few tricks where I can get this in my vise and get a little cold chisel against that and just very carefully tap that out so that it will sit in there properly and run true again. So this stays attached to the axle, and the hub runs over the top of this. So you have to, and I mean, there's another boo-boo, you have to pack these grooves full of grease. If you don't, you're going to run this thing dry and it's going to fail. So that's a very simplistic situation, and these are something that farmers back in the day took these apart and supposedly serviced them every year. It's recommended that you do so that they get re-greased every year. Well, I know a lot of farmers, and they don't fix it if it ain't broken. So that's the theory on that. My grandpa was that way too, but he was pretty good at doing service work on his tractor. That's why that Farmall H lived the whole length of the time he farmed it, because he made sure that thing was always greased and everything was taken care of and it was stored inside and all that stuff. So, long story short, I wanted to show the seal because I'm going to pick up where I left off here, and we're going to start with fixing this first, and we're going to straighten this out first, and I'm going to try to get something set up with that Mickey Mouse thing and do that. I'll have to set up some lighting because I'm losing my daylight. As you can see, I'm losing daylight fast. I should have been doing this earlier, but not enough of me to go around these days. Again, that stuff over there, and we have welders to be able to do this. I mean, there's a plasma cutter over there, there's a 250 Hobart, there is what we call Barney the purple dinosaur. She is a dinosaur of an Airco welder, and it's set up for doing aluminum welding, and it does an incredible job at aluminum welding. Ran a spool gun on it for that. I can also weld some 20 feet up in the air with the spool gun and switch over to steel. The frequency that this thing puts out is just perfect for anything you'd ever want to do. I don't care if it's aluminum or steel or whatever you want to do. That's why I bought this thing, because it was a multi-purpose tool. You can weld stainless with it. You can just weld anything with it. It's older than Mother Time, let me tell you what. And I'm sure you couldn't get parts for it, but it don't need nothing. It just is bulletproof old beast. And with the way they made these welders back in the day, this old Airco is just nuts. I have a torch and oxyacetylene set up for that, so gas welding, and I do have some really interesting tools for jeweler torch heads and different things like that, so I can do a majority of any kind of welding you'd ever want to do. My phone is blowing up with notifications. But again, we're going to fix this at some point. I just can't put it up on a priority level. at this point because there's too much going on in the shop. It's fall, it's harvest time. There's been a couple farmers that brought me stuff to fix and weld for them, so I was doing that. Oh, and my LTEC 160 has been with me since, oh my God, the 80s. This is a very outdated machine, and it's a 160 amp machine. It is set up with 030 wire, so it is great for auto body. I can switch it over to 023 if I want to and do sheet metal welding that way. It just does a fantastic job in a multitude of applications up to about 1/4 of an inch, from paper thin to 1/4 of an inch. It's a very, very articulate little old girl there. I bought it specifically for the body shop for welding spot welds, roughly, putting cars together, you know, back in the 80s. Again, the 250 Hobart that's in the corner, I don't know if you can see it there, but that's when I need to shift gears and I need to go to welding this stuff, because that will weld up to 3/4 of an inch thick steel and do a phenomenal job of laying down some serious beads. And it will work for this job because we only have about a 1/2 inch, we only have a 1/2 inch here of thickness. But we're going to preheat all this so this hardness is equalized. These metals will flow together so they become one and they won't crack. Because otherwise, if you just try to run a bead over the top of this around the outside, all this being not welded in the middle, it would break in a heartbeat. It might even break before the first bounce you hit. So it's got to be welded solid. Then it'll have to be machined off. Let me explain this process a little bit in depth, how this happens. So this is going to be what's called a lap weld. You're going to go one weld over the other weld, and all the time you're going to continue to bond these metal pieces together in the fashion that my finger's going with your weld, so that you're melting a little off this and a little off this, and you're just filling and bonding the metal together. Then when you get it up to this level, grind whatever you got going on off of this, and then I will cut out of 1/4 inch steel, I will cut strips that go from here across here and onto this piece. Then I will down weld those on either side for strength. Okay, so this is actually going to end up to probably be twice as strong as what it originally was. And the only reason I'm going to that extreme is because the potential for this to break on either side of the weld, due to the general metallurgy of what's going on here, because these are dissimilar, you know, to the weld material. And this is cast steel, as you can see. So the chances of it wanting to break again are pretty good. So there's a way to circumvent all that. And that is obviously heating the metals before you weld them so they flow better into each one another. And then to keep from cooling too fast. When you get all done, that thing's going to be hotter than holy hell, and you just don't put it in your water because you'll crack it for sure. Just walk away and let it cool naturally, and if you don't hear it go snap, then you're good to go. And I will probably let this cool a great deal before I start welding the straps on it, just because it's a good idea. I mean, it's just going to be so hot, and so you're not going to want to touch it anyway. If you do, it'll, through super, super thick gloves, those welding gloves right there are nowhere near thick enough to handle this piece of metal, because it's going to be, oh my God, probably 700, 800 degrees, more than likely. This whole thing is going to heat sink all the way up through it. It's just going to be ridiculously hot. And but the best time to weld those pieces on the straps on is when it is very hot, because then you'll get excellent penetration. And you got to make sure you're super, super clean. That's why everything will be sandblasted, so there won't be any potential for stuff to get in the way. This is going to happen down the road. I don't want to get in too deep in this, because this is going to end up to be too long of a video. What do you want? Go away. That cat follows me everywhere. I call it Puppy Kitty. So I'm going to go after this, and I'm going to get this fixed, and we'll take you on that little ride first. And hopefully I won't have to edit out too much of this stuff, but super long videos to me are just nothing less than boring, so I don't really want to ramble on. I want to actually get some work done here. So I'll be back. So as you can see, on this part right here, I already fixed the worst of one, but this is the one that I'm going to take on next, which I'm going to have to not hold the camera here, and so you won't be able to really see what I'm doing anyway, but so I'm just going to do a little before and after here, because I have no way to hold my camera like this. All you fancy YouTube guys have them fancy GoPros. If you want to donate one, I'd be much appreciated. But anyway, I'm gonna basically what I'm gonna do, just to explain this, is I'm using a chisel with a not a very sharp edge on it, and I'm gonna take and pull back the seal. Whoops! I'm gonna pull back the seal and just get underneath this edge, and then very carefully, you can see I'm right on the edge. Very carefully pound this back so that this rubber. And then that rubber, of course, I'll push it all back, but then that rubber will run true in that seal groove again. And so that's what I'm going to do right at this moment. Be right back. Okay, so now that that's done, you can see that this rubber is just a little bit out of whack there, and I've drove that back, and then that really bad one was like over here, and I straightened that. And it's going to take a while for this to get happy, the rubber to get happy and stuff like that. But you can take your fingers and just push it back. Let me see a second here. Take my thumbnail and get in that groove and just work it back a little bit. And then you kind of get it straight again. And you can see that it's going to be just fine. There's some grease in there, but that's good, because you want grease in there. So you just work this rubber back and forth a little bit with your fingers, and it gets happy and goes and so on there. But again, when you put this on, you're going to want to fill this full of grease anyway. You can see how distorted that rubber is still. Oops. Turn it. But the seal itself is straight as a string. And you just, but don't get carried away when you clamp it in the vise and crush the hell out of it, because then you're really defeating the purpose. You don't want to crush that lip, you know. This is on the inside, so it's not that big a deal, but you just don't want to abuse the hell out of it, because you're going to ruin that edge. And if that's dinged up or bunged up, you probably want to bend that over a little bit more. You can see there's a little gap there that could use a little bit of tapping, but I don't want to overdo it. This side has to stay super straight, and as you can see, it is very straight because it's got to run true in the hub. And this stays fixed to the axle. It gets pressed onto the axle, okay, so it stays fixed, and this seal just is filled full of grease, and the hub runs over the top of it. So that's how that works. So I hope that explains this whole situation, and we're going to move on to the next part of the assembly. So I'm going to pick up here on, I guess we're going to end part one. As you can see, this hub's all cleaned up. So things might get a little convoluted here as far as the video footage, but I wanted to show, I left off with the seal, you know, the seal and how that rides on the shaft, and I wanted to show you guys how this actually works. Is this sits inside here, and this thing's pretty loose. It's just really grooved in here. So what I'm going to do is, this is actually going to sit way back here, but it's still super loose, so because it's worn so badly. And I'm not going to get another seal, so, and this is not like being driven through water and in rain and all kinds of things, so I'm not too overly concerned about it. But this just gives you an idea. It sits inside here, and this is fixed to the shaft, pressed onto the shaft, and it just spins freely in here. Now, I wouldn't be a bit surprised if the replacement part that they sell today is a seal that drives into this bore and has the lip seal on the shaft, which makes a lot of sense for it to be that way versus this old style seal. I don't know if they make it like this anymore, if they make it like it was, or if they created a lip seal, or what they're doing. I have no clue, because we're going to make do. So this is going to get super packed full of grease. This is going to be packed full of grease all the way around here. And we're going, so once this, you know, hub goes on the shaft, because this will be part of the shaft, and then this is going to slide on when you put the bearings on. So when I slide it on there, I'm going to go behind it, and I'm going to pack the living hell out of the back of it with grease. Probably get a whole bunch of dirt on it and everything else, but, you know, over time, but it will seal good enough for what service that I'm going to be using this tractor for. As you can see, it kind of sits there. So this will be good enough, and I'm going to end this now on this to explain the seal thing, and I'm going to go into part 2 at this point, which you'll probably see this still be nasty, because this is being, I decided to break this up because this is going to be over an hour and a half long, and I don't want to lose my audience. So anyway, so we'll reconvene on that, because the next part of this, we're going to be talking about this side a lot. So anyway, like and subscribe if you want. This is going to be a 3-part series on this putting the spindle in this tractor, because there's just all kinds of stuff that keep popping up that you're just not going to believe it. Anyway, have a great night or a great day.